Hello, so this is the second medium problem for this weekly contest. Um, for this weekly contest, I would not make a video for the easy one because the problem was too easy. Normally in coding interview, even in FANG companies, you will only be asked about medium problems. Sometimes also easy because some companies do two problems at an interview session. That's why I'm concentrating most of my video into that category. Now about this second medium problem, minimum lines to represent a line chart. So basically we have an array stock prices, which is for each member of the array is actually another array which contains two components. The first component, index 0, is the day, and the second index, the index 1, is actually the price of the stock. And a line chart is shown like this. So if you can see here, this is charting. This point is actually the point of the stock price, is the day and the price. The day and the price. And then the question is, we need to calculate the minimum number of lines that is needed to draw this line chart. So imagine that all this point is being laid out. After it is being laid out, we draw a line there. Okay, the unique point here, if you notice, you see this 3 point that is actually in line. So rather than having to draw it with two lines, actually this is at minimum we can make it into one line because we can just use one line to connect the 3 points. Okay, so that's basically what is the question here. So whether if we try to convert this question into another term is basically where how many points that actually are can be represented with the same line. That's how we minimize the number of lines. This is another example. You see now there are 4 points being represented with one line. This one is just 2 points. This one representing another 4 points. So at minimum, we can represent the line chart with 3 lines. That's why the resolution is 3. Okay, and this is the problem, and so forth. Okay, so now that we have all these things, we'll first try to explain the tactics. Later on, I'll explain the code implementation. Regarding the tactics itself, if you notice, the key point is to understand that minimizations comes when we can find that those points are actually in one line. So what is one line? One line is, if we remember in mathematics, is y equal to mx plus c. Y is coordinate y, x is coordinate x. In this case, the y is the price, x is the day, m is the slope, and c is the constant to add. So this is how a line is mathematically represented, a linear line, of course. From this, another we can say is about the slope. The slope is well known to be able to be derived when we have 2 points, while these 2 points are representing by this. So these are the basic knowledge that we need to know in order to be able to solve this. This is, I think, at least in my country, it was like in junior high school. So using this, as long as we know the points, it means we know the slope. As long as we know the slope and 1 point, we can understand the c. While the c, if we just try to convert it, it means it will be y minus mx. So if we know 1 point, for example y1, and we already know the m derived when we know 2 points, we can find the c. So In order to know whether points are actually within the same line, it means that we need to know about the M and the C. If the M and the C of the new point is the same with the previous points, it means they are still in one line. So that's how we will count the number of minimum lines. Another thing is we need to see the problem. Nowhere in the problem it ever says that the stock prices are sorted from the smallest day to the bigger. The only thing they say is the they are distinct. And then if we check the example, we can see that it is not sorted. So one of the first thing we need to do is we need to sort the data. Why? So that we can do it sequentially to check for whether the points are within the line. So after we sort this, it means now when we go through the sorted list in order, we will go through each point sorted by the day, because in sorting, of course, it will be sorting the first component first, which is the day. Once we already able to be going exploring the data from the smallest day to the biggest day, it will help us to do a sequential check of the number of lines. The first check actually can only be happens once we go to the point number 2. In this point, the second data basically. In this point, what we will do is we will calculate the M and the C based on this formula before. Okay, and then of course, because it is the first one, it will definitely counting it up, right? We don't have yet the MNC of the previous. It will be the very first. It means we will count up the number of lines. Then after that, when we go through the second, we need to remember one thing we need to remember is the previous MC. Then we calculate another MC. MC here will be with the previous point. Okay, and then we compare the MC calculated with this new point with the one we calculated during our exploration before. If it is the same, then we don't count up the number of lines because it means it's still the same line, and so on and so forth. So that's basically the high level tactics. But the code implementation in Python itself, remember, first of all, we will sort our data points so that we can go for the exploration from the first day to the last day. After that, we are preparing this counter variable, which is going to count up the number of lines, and then we will return it. And then remember about the pointer. We will first initialize the initial data point as our P1. And because in order to calculate M, in order to have this formula, we always need two data points because the slope can only be calculated if we have two data points. So this is the P1. Signature here basically it's about the M and the C. Okay. And then what happened here is this is actually a function to calculate what it's meant by the signature. This is basically calculating the numerator and denominator. If you notice, numerator and denominator, because the first index is y, the 0 is the x coordinate, right? And then after that we also have the c here, basically the same function here, but in this case I'm just using the p2. Using p2 or p1 are the same because if they are within 2 points that making the line, the c will be the same regardless of which point you use to calculate it. And then to return it, this is basically an integer division of this numerator and denominator, and this is the remainder. So the two of these will reflect the slope. You don't really need to do this actually, but just be careful about the floating point numbers. And then for C, it will be calculated like this. The C point will definitely be safer in terms, because if you notice, all of these stock prices are integers. I think they said somewhere here, to the integer array. That's why it almost guaranteed. I mean, we can be a little bit safe, little bit comfortable to assume that the C will have no less will have a low probability, or not possible at all, that the C will have a floating point problem. Of course, in the end, we still convert it to strings to avoid some floating point potential issue. Um, I can't remember exactly whether Python have that floating point issue, because the one that I remember was in floating point. There is a specified box where in certain numbers it will do a wrong rounding or something like that. That's why, as much as possible, we need to convert it into something that is more stable to do the comparison. And then that's about this MC. Basically, that's about initializing it and then preparing the way to extract the M and the C of the line formula. Then we now exploring the data point from the first index number 1, which is the second data point, to the top. And that will be, for each of it we will consider it as the second point, P2. And then the current signature, we will calculate it using this function between the 2 points. And if there is not yet any signature, it means it is the first in the index number 1. We will count up the number of lines that we need. Or another thing is, if the current signature is not the same with the previous signature, then we also will count up the number of lines that we need to draw the line chart. After that checks, what we need to be prepared for the next iteration, meaning the current signature become the previous signature, and the current P2 become the P1, and so on and so forth. So that's basically the logic, and then after that, finally, we return the result. Now, how about the time complexity? The time complexity, the calculation itself is just a bunch of minus and divisions. So this is, you can say, big O1. Sorting here is big O and log n. This is just equal. This one, this is big O(n) because it's looping for all of the stock prices data points. This is just equal. This is calculate. Calculate is just big O(1), just comparison, just increment, equal. So this is in total just costing us big O(n). Then when we go to top bottom, sequential means summation. Summation in big O means we took the largest. So the time complexity is big O and log n, which is the cost of sorting this. And that's it. Now let's just do some verification that the speed is enough to be accepted as a solution. And it is. One thing that I will like to highlight for this problem is be careful in terms of the order what you do. Okay, because this could be problematic. For example, as simple as if I just move it like this, when I'm doing the multiplication first rather than the division first. The problem will be, mathematically it looks the same, right? But remember that this is a programming. It become a wrong answer because when we give the multiplication first, it risks us into getting into overflow. Variable in programming has a maximum capacity. So that's why we need to be careful about the order we do our formula. Remember about uh, edge cases problem, like the possibility of getting overflowed. The value for this test case for us is quite big. That's why if you do multiplication first, this is going to be a problem. Actually, that was one of the thing that I was spending time with when I'm doing this contest, just because of that thing. Luckily, I noticed it. So, what mathematically the same might not be giving you the same thing in the programming. Programming has hardware, has limit in their specification, and we have to be careful about it. uh, Most modern programming and the hardware nowadays actually make us less have to be concerned about it, but it still exists. So that's about it. Thank you for listening in.